Welcome, learner, to today's deep dive. So picture this. You type a question into your screen, right? Just a problem you've been, well, stuck on for like an hour.
Oh, we've all been there.
Yeah, exactly. You hit enter, and the AI just instantly generates this confident, highly polished, incredibly detailed answer.
And it looks so good at first glance.
It looks amazing. You read it over, you try to implement it, and then you quickly realize that it is completely, entirely wrong. It just made something up.
Right. It just hallucinated a whole solution.
And we love to blame the machine when this happens, you know? We call it a hallucination. We say the model is broken or it's stupid. But today, our mission is to look at a framework that suggests a somewhat uncomfortable truth. The real problem isn't the AI's hallucination. The problem is your bad question.
Ouch.
Uh,
Yeah, it is a harsh reality to face, but a totally necessary one if you want to get any real utility out of these tools. We are treating this highly sophisticated technology like a magic 8 ball, basically.
yeah, just shaking it up with vague queries.
Exactly. And then acting surprised when the answers are just murky or completely off base.
And shifting that dynamic, moving from a frustrating guessing game to a genuinely powerful thinking partnership. That is our mission for this deep dive. But before we get into the mechanics of how to actually do that, we have a really fun reveal for you listening.
We do. This is exciting.
We are actually working for Skill Wanderer. Everything we are breaking down for you today is built directly from their learning material. It comes straight out of the Skill Wanderer Dojo platform.
Yeah, and we are just incredibly proud to be bringing this material to you. The Dojo is a free open access platform. And, if you find the mental models in today's deep dive valuable, we strongly encourage you to check out the full course.
Highly recommend it.
You can find it at https://dojo.skill-wanderer.com/coursei, First Learning for Tech Careers. And what is truly brilliant about their approach is the multiple model learning formats.
Right, because everyone learns differently.
Exactly. You can experience this exact material through video, audio formats like this podcast, slide presentations, or even just deep dive reading. It caters completely to whatever format makes the concepts click best for you.
So today's specific source material is Lesson 3. It's titled Asking Better Questions, and that sits in Module 1 of that AI First Learning for Tech Careers course. And let's just jump right back to that opening friction.
To it.
The dominant narrative out there is that AI is inherently inaccurate, but the source material throws cold water on that idea. It argues that we're asking fundamentally incomplete questions, and the AI is just giving us confident guesses in return.
It really forces a bit of self-reflection, honestly, because the AI doesn't actually know what it's talking about in the human sense. It is doing exactly what you asked it to do with the very limited parameters you gave it.
Okay, let's unpack this. Wait, people blame the model when it gets things wrong.
Yeah.
And to be fair, sometimes it is the model's fault, right? Like,
Right.
we've all seen AI just invent completely fictitious historical events.
Oh, absolutely. The classic fake legal cases.
Right. Or it confidently does basic math wrong. So we can't let the models completely off the hook and put all the blame on the user.
What's fascinating here is that the source text completely validates your point. Yes, absolutely. Model issues exist. Architecture limitations exist. Sometimes the problem does start inside the neural network itself.
What?
But, and this is the crucial distinction here, a huge percentage of those quote-unquote bad answers actually start much earlier in the pipeline. They start at the keyboard.
Because AI isn't human.
Exactly. It doesn't naturally pause, look at you, and say, hey, wait, what exactly do you mean by that?
Right, because it doesn't have a human ego. And it doesn't have human hesitation. It's a prediction engine.
Precisely. Under the hood, these large language models, they're designed to predict the next most likely token or word based on the prompt you gave it. Its core directive is just to continue to infer and to produce plausible output.
It just wants to be helpful immediately.
Yeah. So if your prompt is missing important context, the AI doesn't stop and give up. It mathematically fills in the blanks. It builds a hypothetical scenario based on statistical averages, and it confidently answers the wrong version of your problem.
So if you let AI read your mind, you are literally instructing it to hallucinate.
You're forcing its hand. Yeah.
Let's make this super concrete for you listening. The source gives this perfect technical example of a bad question versus a better question. Imagine you're a developer and a site you manage is just dragging.
The worst feeling.
The absolute worst. So the bad question, the one almost everyone defaults to out of just sheer frustration, is typing. Why is my website slow?
Which, if we think about the mechanism we just discussed, gives the AI almost nothing to work with. So the model broadens its probability distribution,
You cast a wide net.
a massive net. It's going to give you a generic list of every possible reason a website has ever been slow since the dawn of dial-up. Check your image sizes, check your DNS, check your server load.
It's the equivalent of Googling, why does my car make a noise? You just get more confusion, not a solution. Now let's look at the better version from the lesson.
This is where it gets good.
Instead of, why is my website slow? You type. My Nuxt SSR site deployed on Cloudflare pages loads slowly for US users with TTFB around 2.5 seconds. My backend is in Vietnam, but SSR runs on the edge. I want a diagnosis and next steps. I am not sure whether the issue is cold start, network distance, or slow data fetching.
The difference in the output you will get from that, it's just night and day.
Let's briefly translate some of that jargon for anyone who isn't living in web architecture every day, because it's the structure of the prompt that actually matters here.
Right. The specific tech doesn't matter as much as the framing.
Exactly. So SSR means server-side rendering. The server is building the web page before sending it to the user. TTFE is time to first byte, meaning the user's browser is just sitting there waiting for the server to say anything at all.
And then there's the crucial geographical context.
Yes. The database is in Vietnam, but the edge servers trying to build the page are in the US.
By providing that, you drastically narrowed the AI's probability space. If you just ask, why is it slow? The AI assumes a standard localized setup. But by telling it the backend is in Vietnam and the edge is in the US, you are giving it the specific parameters of your unique architecture.
You've taken hidden assumptions like geographic latency and made them explicit data points. You went from a vague complaint to a clear professional brief.
And this leads to what I think is the biggest mindset shift in this entire text.
Yeah.
We tend to treat AI prompting like it's coding, like there's some secret syntax or magic phrase that unlocks the right answer. But AI prompting isn't just a technical skill. It is a human communication skill.
Oh, that makes so much sense. It requires the exact same cognitive muscles you use to explain a complex problem to a new coworker.
Exactly. People who communicate well with humans often excel with AI because they already understand how to establish shared context. They know how to define the boundary between what they know as a fact and what they are just guessing.
Which begs the question, if we know vague prompts cause the AI to guess, and guessing causes hallucinations, how do we systematically build that better question before we hit enter?
We need a system.
Right. I know the lesson provides a framework, but I have to push back a little here. Writing a 4-sentence, highly detailed prompt for every single question sounds kind of exhausting.
It does sound like a lot of work.
When I'm trying to move fast, I don't want to write a novel just to get a snippet of code or a quick answer. Where is the actual return on investment for doing all this prep work?
See, that is the exact trap most users fall into. It feels faster to write a 4-word prompt. But think about the hidden cost of that quote-unquote speed.
The debugging phase.
Exactly. You write a 4-word prompt in 2 seconds. The AI gives you a flawed answer. You spend 20 minutes trying to implement it, it breaks. You get frustrated, you write another vague complaint, it gives you another hallucination.
It's a vicious cycle.
It really is. You can either spend 2 minutes writing a structured brief up front or 45 minutes debugging a hallucinated solution on the back end.
When you frame it like that, the 2 minutes up front is a massive time saver. So how do we actually structure it? It's kind of like walking into an emergency room, right?
I like that analogy.
Yeah, if you walk up to the triage nurse and just say, it hurts, without pointing to where, without explaining when it started, and without sharing your medical history, they can't help you. You have to treat the AI like a highly capable but completely blind consultant.
That's spot on. And to help us do this systematically, the Skill Wander lesson provides a specific framework to use before you engage the AI. It's the PCGU framework.
PCGU.
Yeah. That stands for Problem, Context, Goal, Unknown. 4 short lines.
Let's roleplay building one of these rather than just listing them off. So P is for problem. The text says this needs to be a flat statement of what is actually happening. No theorizing yet, just the symptom.
Right, just the raw facts.
So my database queries are taking 5 seconds to resolve.
Perfect. Second is C for context.
Yeah.
What does the AI need to know first to truly understand the environment that problem is happening in?
Like giving background files to an accountant.
Exactly. If you hire a forensic accountant, you can't just say, find the missing money. You have to give them your ledgers, your corporate structure, your vendor lists.
So for the database issue, the context would be, I am using PostgreSQL, hosted on AWS RDS. The table has 50 million rows, and I am querying it using a wildcard search.
Which is fantastic context. Without that, the AI might suggest solutions for a small local database, which would be totally useless to you.
Right.
Third is G for goal. This is where you dictate the format. What kind of answer do you actually want? An explanation, a diagnosis, a comparison table, a step-by-step migration plan.
So I might say, I want 3 prioritized next steps for optimizing this specific query, formatted as a bulleted list.
Nice and specific. And finally, U for unknown.
Yeah.
What part of the system is a black box to you right now? What are you actively trying to figure out?
I am not sure if the issue is a lack of indexing or if my wildcard search is just inherently unoptimized.
And there you have it. Problem, context, goal, unknown. You aren't just decorating a prompt with polite words. You are performing fundamental problem definition.
You are mapping out the boundaries of your own knowledge before you ask the machine to fill in the gaps.
Precisely.
Now, you listening, try applying that mental shift next time you are stuck. Before you fire off a frustrated question, just mentally map those 4 points. What's the raw problem? What's the surrounding context? What specific output do I want? And what exactly do I not know?
But, even if you execute the PCGU framework flawlessly, we run into another fascinating quirk of how these models operate.
Oh.
Yeah, AI might still make massive leaps in logic.
Here's where it gets really interesting, because we just built the perfect prompt. We gave it the context, the exact goal, the knowns and unknowns. How do we actually force the AI to stop nodding along like a yes man and reveal what it's secretly assuming about our perfectly crafted prompt?
This raises an important question about model alignment. These models are heavily fine-tuned to be agreeable and to follow user intent.
They just want to agree with whatever we say.
Right. Unlike a strong human expert who will naturally slow down and say, okay, let me make sure I understand your premise, the AI tends to just accept your premise as fact. It answers first, and it will only clarify later if you really force it to.
It wants to please you immediately, even if your premise is fundamentally flawed.
Exactly. So you have to manage those assumptions directly. You have to explicitly instruct the AI to expose its blind spots, to break that agreeable programming.
So how do we do that?
The lesson provides a few highly effective instructions you can append to the very end of your prompts to force this behavior.
Let's hear them, because these are the kind of tactical additions that just change everything.
First, you can simply add, list the assumptions you're making before you answer.
Wow, simple. It forces the model to articulate its own baseline parameters.
Yeah. Second, if anything is unclear, ask me first instead of filling in the gaps.
That is brilliant. You are explicitly overriding its core directive to just continue. You are giving it permission to pause the prediction engine and ask a clarifying question.
It's a game changer. A third option is, tell me which part of your answer is most uncertain.
I like that one.
And finally, you can ask, what information is missing that would change your answer?
What information is missing that would change your answer? I want to linger on why that one is so powerful under the hood.
Yeah, let's look at that.
When you ask that, you are forcing the AI to evaluate the boundaries of its own context window. It has to look at the solution it just generated and then mathematically reverse engineer what variables could shatter that solution.
It exposes the fragility of its own advice.
Exactly. Now, managing assumptions directly like this doesn't permanently cure hallucinations. But by making the guessing visible, it drastically improves the safety and quality of the interaction. You aren't just blindly following an answer. You're getting a map of how the AI navigated to that answer.
You are actively managing the cognitive process of the AI, rather than just passively receiving its output.
Which brings us to the final phase. Let's say you've done it all right. You use PCGU to build a great brief. You appended an instruction to expose assumptions. You hit enter, and you get your first genuinely excellent answer back. Are we done?
You would think so, right?
Do we just copy-paste the code or the strategy and walk away?
According to the Scale Wanderer approach, no. That first good answer is not the end of the process. It's just the baseline.
Think of it like calibrating a navigation system. The first prompt just gets you pointing north. But the actual journey, the actual learning, requires continuous recalibration.
Right.
If you stop at the first answer, you get a quick fix, but you don't gain any actual knowledge.
The lesson refers to this ongoing recalibration as the loop.
Yeah.
You ask that better first question, you get the initial answer, and then you run the 5-question drill. And this actually references lesson 2 of their course, reinforcing that this is a cohesive AI-first learning system.
Let's actually apply this 5-question drill to that earlier example of the website with the backend in Vietnam and the edge server in the US. Let's see how this creates actual understanding.
Okay, so the AI gives you an initial diagnosis about network latency. Question number 1 of the drill. What is happening here in plain language?
Getting rid of the jargon.
Exactly.
Yeah.
You use this to strip away the jargon. The AI might explain, your server in the US has to literally send a signal across the ocean to Vietnam every time a user clicks, and that physical distance takes time.
Question 2. Why does it work this way? This moves you from the what to the mechanism. The AI explains the mechanics of fiber optic cables, the speed of light, and how TCP handshakes require multiple round trips across that ocean.
Question 3. How does the mechanism produce this result in my specific situation? This grounds the theory back into your reality. The AI connects the TCP handshake latency directly to why your specific Nuxt SSR site is showing a 2.5-second delay for your US users.
Question 4. What assumptions is this answer making? Always check for hidden leaps in logic.
Always.
The AI might reveal, I'm assuming your database isn't caching any of this data at the edge, requiring a fresh pull from Vietnam every single time.
And finally, question 5. When would this fail? Or when would a different answer be better? This maps the boundaries of the solution. The AI might say, if your data in Vietnam updates every second and must be perfectly real-time, caching at the edge will fail, and you need a completely different architecture.
So what does this all mean? We've built the context, we've controlled the assumptions, we've run the 5-question drill to understand the underlying mechanism.
It's a lot of good work.
It is. But there is one final step the lesson demands to lock this in. It's called knowledge extraction. After this rich conversation, you don't just close the tab. You take a moment to write down 4 short lines for yourself.
This is where you consolidate the external information into internal knowledge.
Exactly. You reflect and write first. The real problem was.
Yeah.
Because often your initial problem wasn't the root issue.
Almost never.
Right. In our example, the real problem wasn't Nuxt or Cloudflare. It was database geography. Second, the context that mattered was, what specific detail completely changed the AI's diagnosis? In this case, the physical location of the backend.
Third, the key assumption was, what was the hidden trap you had to check? Here, it was the assumption about caching.
And finally, the next move is, what are you actually going to test or verify in the real world now?
The source material stresses that this extraction process is how you turn one isolated useful answer into a repeatable, compounding learning habit. You are quite literally training yourself to be a sharper, more rigorous thinker, using the AI as a sparring partner to expose your own blind spots.
It is a complete paradigm shift in how we approach these tools. So let's quickly retrace the path we've taken today. We started by dismantling the comforting myth that bad AI answers are entirely the machine's fault.
Right, exploring how the model's next token prediction engine is forced to guess when we provide incomplete context.
Then we learned how to fix that using the problem context goal unknown, or PCGU framework, to build a comprehensive brief, just as we would for a human consultant.
We then explored how to break the model's yes-man programming by explicitly instructing it to reveal its guesswork and evaluate its missing information.
And finally, we saw how the first answer is just the start of the loop. We use the 5-question drill to dig into the underlying mechanisms, and we extract that hard-earned knowledge at the end with 4 reflective lines.
Beautifully summarized.
By applying this framework, you are transforming AI from a simplistic, often frustrating slot machine for answers into a dynamic, rigorous thinking partner.
It really is a methodology that turns everyday troubleshooting into a continuous engine for skill development.
I could not agree more. And I want to remind you that this entire framework, these mental models, come directly from Lesson 3 of the AI First Learning for Tech Careers course.
Yes, from Skill Wanderer.
We are incredibly proud to be working with Skill Wanderer to unpack this for you from their Dojo platform. If you want to dive deeper and truly master these skills, you need to check out the full course. You can find it at https://dojo.skill-wanderer.com/course First Learning for Tech Careers.
And remember, the dojo is free, open access, and built on multiple model learning formats.
Which is just so cool.
It really is. Whether you retain information best through video, a podcast format, visual slides, or deep reading, they have structured the material to match your learning style perfectly.
It is an indispensable resource for anyone who wants to move beyond just casually using AI to actually leveraging it for career growth.
Absolutely.
So as we wrap up this deep dive,
If we connect this to the bigger picture, we've spent our time today analyzing how to communicate more effectively with a machine. But the underlying principles of the PCGU framework, providing clear context, defining goals, and exposing hidden assumptions well, they overlap entirely with good human communication.
oh, absolutely they do.
So I want to leave you with a thought to explore on your own. If interacting with AI is ultimately a stress test of our human communication skills, How might practicing these structured AI prompts actually change the clarity and precision of how you talk to your human coworkers, your managers, or your team tomorrow?
Now, that is a thought worth taking with you into the rest of your week. Thanks for joining us on this deep dive, learner. We'll catch you on the next one.